In your conceptual video, you learned a little bit about work and energy. You learned that energy was defined as the ability to do work, and you learned that work is the amount of force applied to an object times the distance that it moves. Now in AP Physics, we're going to take this a little bit further. We're going to further define this a little bit more clearly as the force times the displacement times the cosine of the angle between the force and displacement. So therefore, if you had a force and a displacement and they were not in the same direction, that angle between them would be a factor. One of the consequences of this is that if the force and the displacement are in the same direction, you can ignore the cosine, because the cosine of 0 degrees is 1. If the force and displacement are opposite directions, you'll get negative work done because the cosine of 180 degrees is -1. But also, if the force and displacement are at a right angle to each other, you will have no work done because the cosine of 90 degrees is 0. When you have a box resting on the ground, and let's say you were to pull on this box with a force that was in an angle, there are a lot of forces acting on this box. For instance, there's the weight. Also, there's the normal force. And you might even have friction. If we were to move this box some displacement to the right, work would be done. Let's imagine that we're moving this box at a constant velocity, which means we have 0 acceleration. If we were to look at each force individually and figure out how much work got done, let's start with the applied force. So in the case of the applied force, the work being done by the applied force would be the force times the displacement times the cosine of that angle that's between them. And you get some value. If you were to do the work being done by the friction force, you would have the friction force times the displacement times the cosine of 180 degrees, because the angle between the displacement and the friction force is 180, which would give us negative force of friction times the displacement. If we were to look at the normal force, we would get that the work done is the normal force times the displacement times the cosine of 90 degrees, which is just 0. And finally, the work being done by mg, or the weight, is mg times the displacement times the cosine of 90 degrees, which again is 0. These are the kind of calculations that you need to be able to do for work. In the next video and the next worksheet, we're going to look and see how the concept of work applies to energy. By the way, the unit for work is the same as the unit for energy, which is the joule. And what we're going to find out very soon is that the reason work is related to energy is because work is how objects are given or have their energy taken away.